Okay, so we've already worked with the extreme value theorem, which says that if your function is continuous on an interval from a to b, so if your function goes from the interval a to b, and so that's kind of what it looks like, and it's continuous, which means it has to be drawn without lifting your hand, then there has to be a maximum and there has to be a minimum. So now what if the interval is not closed? So there are many functions in the world where the function extends on and on forever. So what if your function does kind of like that, that kind of shape? I don't know. So turns out that if the function has one minimum or one maximum, then that minimum or maximum is going to be an absolute minimum or an absolute maximum. So if you have one critical number, that critical number is going to be an absolute max or an absolute min. So in this case, it's a minimum, and it's the only one on the graph. So we're going to be calling it an absolute minimum. Okay, let me do it again. Absolute minimum. Okay, so again, an absolute minimum could be called the minimum if you want. Similarly, if my function kind of looks like this, if I have a single critical number, that single critical number in this case will be a maximum, and as a matter of fact, it will be called an absolute maximum because it is the only one on the whole graph. Let's go ahead and practice that with the next problem. So it says, find the absolute maximum or minimum of the function f of x equal to 4x minus x squared. So again, we're going to start by looking for the derivative. It's always the same as usual. 4 is the derivative for 4x, and x squared becomes 2x. Now, what makes the derivative equal to 0? This happens when the 4 minus 2x itself is equal to 0. So this happens when 4 is equal to 2x, and that means x has to be the number 2. So far, that's the only critical number. Now, is there a chance for the f prime to be undefined? F prime is undefined. Well, unfortunately, no. Well, maybe fortunately, no. There is no denominator, so the derivative can never be undefined. So we only got one critical number, so the guarantee is that that critical number is automatically going to be an absolute something. It's either an absolute minimum or an absolute maximum. So how do I know? I can now go ahead and do the test that I always do. What's the f prime test going to look like? 2 is in the middle, minus infinity, and then positive infinity. So pick a number before, pick a number after. Let's say I pick 0 before, and let's say 10. So 0 goes into the derivative. So 0 goes into the derivative, we get 4 at the end, which is positive. The 10, however, when you plug it into the derivative, you get basically 4 minus 20, which is negative, something 16, whatever. So it's negative, so that means the function went up, and it means the function goes down. So the 2 is going to be a maximum. As a matter of fact, you can call it an absolute maximum. Okay. And so that's pretty much it. If you try to put this in your calculator, the 4x minus x squared graph, I believe, is going to look similar to this. And the 2 that we're searching for is going to be the highest point on the whole graph. And so it would be called the absolute maximum. So give it a shot. Put this in your y1 on your calculator and see if you get the same sort of graph that I did.